So DeFi, though, is by far and away the largest solution on blockchain. It exploded last year, primarily in the second half of the year. And the explosion is going to continue on through the end of this year as well. So what we have here is a $1 trillion, right, in cumulative blockchain network value in 2020. And this is all documented in the Masari report. .io. I recommend that link at the bottom. And in 2021, $3 trillion. That's mind boggling. $3 trillion are forecast in the blockchain industry. So Algorand DeFi examples include IDEX, Monerium, Polkadot, stablecoins like Tether, USDC that we talked about. These are all examples. More examples here with World Chess and Planet Watch and Republic and Tether. Really, a lot of companies now are on our use case part of the site. The ecosystem is growing leaps and bounds. This is a very exciting time. I remember when I started at Microsoft, I worked for them for about 12 years. That was back in 97. And the feeling was like that then, where you're starting to grow in a company and everybody in the company's excited about it. And everybody in the community is really getting ramped up on that time it was Visual Basic and doing third party controls. And history repeats itself sometimes. When you get a good thing and good technology going, it really does fester to itself. It really builds itself into a big steamroller, which is really great. So over 500 companies now on the Algorand platform. One of the three blockchains with the top two stablecoins, USDC and USDT. Over 1,000 plus nodes, 500 plus ambassadors, lots on this slide. Finally, we'll end this section with some quotes, proven success in Algorand. You got a Testiv over there with excellent documentation. They were up and running just a few days. The transaction fees are really low, right? They've got transaction fees of a 20th of a cent. And then speed and scalability is another big issue. And look down in the bottom right, you got other blockchain platforms. Transaction costs are very expensive and the speed is painfully slow. Algorand is a game changer. So lots of performance capabilities. That's really the bottom line. So let's get into the Algorand basics. So an Algorand blockchain is like an immutable ledger, distributed ledger. So everybody's got a copy of it. And basically there's only a handful of record types in this ledger. You got blocks, which is at a certain point in time. On our blockchain, they're burned every 5 seconds. Now, during that 5 seconds, transactions get written to the blockchain. So it's a read-only blockchain, write once. And when you're writing that block, then you have transactions that are associated with that interval of time. And so now you got transaction information from account to account. So transactions are associated with accounts. And then each account has things like assets, and applications are smart contracts. And assets are something that we are going to be talking more about, but those are your tokens, right, that we've been talking about. So pretty simple when you look at the whole mix here. Now let's talk about how these are actually built, right? One at a time, right? So some of you may have heard of forks or proof of work with other blockchains like Bitcoin, for example, and it takes over 10 minutes to burn a block there. And there's forks that happen where competing machinery is trying to compute equations. It's not green. It's not green at all. And so a lot of times transactions want to be written on that fork, you get orphaned, and then it goes to another fork. So there's a lot of problems, especially when you start thinking about point of sale, scalability, and performance. So with Algorand, we don't use either of those. We don't use proof of work or we don't use forks. Now, what we use is best described here by talking about the Byzantine generals problem back in the day, where you have all of these generals that need to communicate in the empire before they plan an attack. So you have messengers that go around to all the generals that say, okay, how are your supplies? How are your soldiers? What's the weather looking? Are you going to be able to attack if we attack? And then you go around and you get a nice consensus. So if everybody agrees, yeah, this is the time to do it, then we're going to go ahead and boom, we're going to attack. Now, there's some problems here. Number one, the messengers may break a leg. The messengers may get corrupted. The messengers may encounter bad weather. So you won't necessarily have all of the players on board. That's one problem. The second problem is scalability. Once you start involving, say you're at 10 people here, 10 generals, the costs get exponential in trying to accomplish that task. could be 10 squared. But then if you get to like a million people, now you're like at a million squared in terms of the cost, which just doesn't scale no matter what planet you're on. All right. Silvio McCauley figured it out. He's our founder of Algorand. He's also a Turing Award winner. And I'm telling you, I'm in the presence of greatness on this team. It's mind boggling. And so he came up with the VRF, the verifiable random function, the statistic. That's really what it is. You really don't need everyone to participate. What you need is a representative sample. And that's it in a nutshell. So this is how it works. You got your blockchain sitting out there. You get a small random committee of all users, and then the committee agrees on the block of transactions. Every member verifies transactions and digitally signs it. This is where you also check for things like, does the account have enough money to fund this transaction? And are they doing double spending? These are all things that are covered by the protocol. The protocol checks all of this. And then if it all looks good, then the block is added to the chain. And then every 5 seconds, this goes on and it does it again. So that's how it works. That's the key idea.